AQAS Level Chemistry Paper 1, June 2019. Walkthrough. Question 1.1, explain why fluoride ion is larger than the sodium ion. Now, if it's larger, it's going to have a weaker attraction to nucleus outer electrons. So what does that mean? Well, it's going to have a lower nuclear charge for your protons. Explain in terms of friction bonding why the melting point of sodium fluoride is high. Electrostatic force of attraction between oppositely charged ions. I already seen the question. Na plus and F minus oppositely charged ions. Ionic bonding. Lots of energy needed to overcome the forces. Name type of bond formed. And with these type of bonding questions, you just need to be very specific. It's very simple, but it's very key words they're looking for the mark scheme. Name type of bond formed when HF reacts with H+. Coordinate bond / dative covalent bond. A lone pair of electrons is donated from F. Can't be donated from H, can it? So it must be F. Name the shape of each ion. Sb, F6 minus, and draw the shape, sorry. So Sb, F, 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 octahedral shape, square brackets minus charge, H2, F plus, F with two lone pairs of electrons with a positive charge, and it is bent. Use dating table 1 to calculate value for bond length 3 of CF bond in the product. Delta H equals energy required to break bonds minus energy released when new bonds are formed. Minus 179 equals 2785 minus 1996 plus 2y. And this is a trick, right? So then this is 2785 minus this whole thing, right? So this is going to be whatever, a positive number. Then I've got minus 2y, then I'm going to add 2y, and then I'm going to add this, and I'm going to get this, 2y equals 968, y equals plus 484. That's the CF bond enthalpy. Scrap of the molecules are ionized using electrospray ionization. Sample is dissolved in a volatile solvent and injected through a nozzle / needle at high voltage. Each particle gains a proton. Give the formula of the ion that we should detect the first one. TO, time of flight mass spectrometer, the one with lowest MRC, 3H5O2NH+. Give the equation includes state symbols for the process that occurs during the ionization of germanium atom electron impact. So GE gaseous arrow GE gaseous, GE plus gaseous plus E minus, or X gaseous arrow X plus gaseous plus E minus. That's the formula to memorize for electron impact ionization. Using information to calculate mass of grams 1 mole of the germanium ions. So velocity equals distance over time. Substitute that in. M equals 2ke over velocity squared. You've got velocity. You get the mass in kilograms. I want the mass of 1 mole of these ions. So 1.146 times by 10 to the power minus 5 times by Avogadro's constant. But then I also need to times by 1000 because I've got my answer in kilograms. I want it in grams. And I get 69 grams. Therefore, the mass number of the ion is 69. It says, use your answer to state the mass number, so 69. Complete full electron configuration chromium atom. Chromium atom's got a special rule, so just be aware of that. 1s2, 2s2, 2p6, 0s2, 3p6, 4s1, 3d5. Just a symbol, including mass number and atomic number for this atom. Now, if it's got 2 more protons, it's going to be different. So it's going to be iron and 3 more neutrons. Well, then it's going to be 57 on top. Determine the percentage abundance of fourth isotope. 100 minus all the isotopes. 82.8 plus 10.9 plus 2.7. 3.6. Substitute that in. 52 times by 82.8 plus 53 times by 10.9 plus 54 times by 2.7 plus 3.6 times by x or y. Divide by 100 equals 52.09. Rearrange it. Find x equals 50. And it's a show question as well. That's why you need to show all these steps. Use the oxidation state of chromium to Cr2O72 minus sign plus 6 because oxygen minus 2 times by 7 minus 14. Chromium must be plus 12. Cr2 must be plus 12 to get overall charge of minus 2. Oxidation state of minus 2. But 2 chromiums equals plus 12. Therefore 1 chromium is plus 6. Use half equation oxidation iodide ions to iodine. I minus arrow I2 plus 2 minus 2I minus arrow I2 plus 2 minus. Use half equation for conversion acidic solution of Cr2O72 minus ions to Cr3 plus ions. 6E minus plus 14H plus Cr2O72 minus arrow T 2 Cr3 plus 7H2O. Then reduce the overall redox equation times this equation by 3, so the electrons are the same. Electrons cancel out, add them together, you get that. Explain the pattern of first ionization energies of elements from lithium to neon. Stage 1 general trend. First ionization energy increases, more protons, therefore increased nuclear charge. Electrons are also in the same energy level, therefore similar shielding, so stronger attraction between nucleus and outer electrons closer to nucleus. Stage 2 with deviation, beryllium and boron. Boron is lower than beryllium. The outer electrons in 2p orbital, therefore higher in energy than 2s. Stage 3 deviation, nitrogen, oxygen. Oxygen is lower than nitrogen. Why? Because the two electrons in 2p need to pair, therefore pairing causes restriction. Calculate amount of moles of NO and Cl2 in the equilibrium mixture. ICE method, I always like to use this. You got your initial moles. I did do this a bit wrong. This is your initial moles, so this should be on the top, and then 1.50, and you get the point. C is your changing moles, so C is that equilibrium moles of these. And that's what you're trying to find, the amount of moles in the equilibrium mixture. Give expression for Kc. Kc always, whenever I see Kc, I'm always going to write down square brackets, because if you get that wrong, you're going to lose so many marks. Kc is square brackets and then products of reactants. Don't get confused between Kp. I made that mistake one time, and I just don't want to make that mistake ever again. Kc square brackets. And remember to include the square because it's 2 moles. Reduce amount of moles of NOC as equilibrium mixture. So you substitute this in. Volume is this, so divided by 0.800. Move this to the left hand side. Like in the last video we'd walk through, we'd calculate the total pressure of something, given the mole fractions, and move it all to the left hand side, divided by that. You get total pressure equals that with the mole fractions. That's not really relevant, but yeah, move this to the right hand side. Get this NOCl squared, concentration equals this, NOCl, square root it. And then moles, I want to find the moles, not the concentration. Moles, concentration, volume, times by the volume, 0.800 in moles per t minus cube, you get the number of moles of NOCl. Use the results to calculate MR of H2A. Average titer first things first. Why else would it give me this table? Find the average titer 26.4 plus 26.5 over 2. Concordant results 0.1 centimeters cubed within each other. Moles of sodium hydroxide then 0.112 times by 25 divided by 1000. Mole, therefore moles of H2A is that divided by 2 because 2 to 1 molar ratio, 1 to 2 molar ratio. Then to find out the moles of H2A in 250 centimeters cubed, I'm going to use 1.4 times by 10 to the power minus 3, the moles, times by 250 divided by 26.45. This is where the average titer comes to use. You get the moles and mass, moles and mass of MR. MR is moles and mass of MR. MR is mass in grams over the moles, and you get 98.2. And the mass I got from here, 1,300 milligrams, covered into grams divided by 1,000. Calculate percentage of certain using pipette. 0.06 over whatever is a pipette, 25 centimeters cubed. That's what we added with the pipette, times by 100. 0.24%. Explain that air bubble increases the final burette reading rough titration. Air bubble takes up volume that would otherwise be filled by solution/acid. Suggests why this washing does not give an incorrect result. Does not react with the alkali / does not change number of moles of alkali. Give the equation reaction between titanium 4 chloride and magnesium, 2 Mg plus TiCl4 ROTi plus 2 MgCl2. Role of magnesium is a reducing agent. Calculate percentage by mass of magnesium oxide as a mixture, moles of H2O. Quite easily find out mass of what produced over MR. Then mass of magnesium hydroxide, because 1 to 1 mole ratio is number of mole times MR. Then, in order to find out the percentage by mass of magnesium oxide, I've now got the mass of magnesium hydroxide, and I know the total of magnesium oxide, magnesium hydroxide is a mass of this, 3.20 grams. Not I want in milligrams, I want in grams. Therefore, to find out the mass of magnesium oxide, it's 3.2 minus the mass of magnesium hydroxide to get this. Percentage by mass of magnesium oxide, mass of magnesium oxide over the total mass times by 178.7%. State what observed in each case. Use H2SO4, no visible change with NaCl, white precipitate form BaCl2, NaCl and Na2CO3, H2SO4, observation NaCl, no visible change with effervescence, with Na2CO3 effervescence. Which sample measured at room temperature contains greatest number of stated particles, 1 gram of hydrogen molecules, was empirical formless oxide, MO2O3. Which substance has delocalized electrons, graphite. Which species is not pyramidal in shape, BF3. Which change occurs when water is vaporized? This one is a really important multiple choice question because it tests your knowledge and also your understanding of all this kind of stuff. When water is vaporized, obviously B and C, right? That's what you probably might choose between. It's not covalent bonds are broken when water is vaporized. Intermolecular forces are overcome, and I could definitely see this being repeated, so I would definitely learn this one off by heart, as well as the rest of them as well. But which change occurs when water is vaporized, intermolecular forces are overcome. Which equation represents fraction of standard enthalpy change equal to standard enthalpy formation for barium chloride? I'm forming barium chloride, it's got to be in its correct symbols. Well, barium is not a gaseous, it's a metal, so it's got to be solid. Which equation represents redox reaction? Look at the oxidation states and you can find quite easy to see it's D. Which property would you expect the element radium to possess? It forms a soluble sulfate. It does not react with water. Good conductor of electricity, forms a covalent fluoride. I'm not familiar with any of these, but I know radium is a metal. And I know metals are good conductors of electricity. Therefore, immediately I'm going to choose C then. Form soluble sulfate. I've never ever learned about that in chemistry, about radium forming soluble sulfate. I've never learned that it does not react with water. I've never learned it forms a covalent fluoride. You know, these multiple choice questions, they're going to put extremely weird examples to try to trick you out. But just think about, what is the element? What is it? Is it metal? What is it? And then you can quite easily find out the answer. Oh, it's metal, so it obviously it's going to be a good conductor of electricity. That's what I would expect it to possess. Which change because when water vaporized, intermolecular force it will come. Which statement is not correct? Strontium reacts less vigorously with water than calcium. That is not correct. Which property groups the elements Ca to Ba increases atomic number, atomic radius? Which is best oxidizing agent? Now this one, well, F minus and I minus, the oxidizing agent. What is the definition of oxidizing agent? And this is where your knowledge of definitions and all of this comes to play. Even just 1 mark as these multiple choice questions. Well, oxidizing agent is a substance that gains electrons and gets reduced. Well, F minus and I minus, they're already in the reduced form. They've already gained electrons, therefore they can't act. They physically can't act as oxidizing agents, because oxidizing agents is a substance that accepts electrons and gets reduced. Both of them are already reduced form, so they can't accept electrons, can't act as oxidizing agents. So I'm left with A and C. Now, something I need to know, I already know this, but fluorine is the most electronegative element, right? So if fluorine is the most electronegative element, what does electronegativity even mean? The ability of an atom to attract a pair of electrons in a covalent bond. It's something like that, I'm pretty sure. So, ability of an atom to attract a pair of electrons in a covalent bond. So if fluorine is the most electronegative element, it's going to attract the electrons more strongly, right? So therefore it's going to attract the electrons, so it's going to accept the electrons more easy. So which one's going to be the best oxidizing agent? A. Question 20, and this question 19, by the way, this is a pretty hard question. You need to know your definitions because they help you with your understanding, and also you can link all these definitions together. Oxidizing agent, electronegativity, and all of that to get that mark. What is the amount of heat energy absorbed by water? Well, I know Q equals MC delta T. So Q equals heat energy absorbed M, mass of water, times by C, times by Y, which is temperature rise. MC delta T. So yeah. C and D, no way you would probably get that. If you know the formula and you just substitute this in, you ain't going to get C or D. B, some students could fall under the trap because, yes, in order to convert from degrees Celsius to Kelvin, I'm adding 273, aren't I? Yes, you are right. You are right. But remember, when the temperature rise, if it's a temperature rise, we don't care about degrees Celsius, Kelvin. We're not converting between that. It's degrees Celsius. 1 degree Celsius equals 1 Kelvin in temperature rise. So I'm not going to add 273, and that's a very big trap. And that's actually a really nice question testing. Do you know that in temperature rise, you're not converting between degrees Celsius and Kelvin. It stays the same as degrees Celsius. Question 21. 20 centimeters cube of butane to complete the burning this much of oxygen. Which statement is correct? Now I'm going to convert that to cm cubed. So that's 200 cm cubed. A 1 to 6.5 mole ratio. So ideally I should have I do have 200 centimeters cubed, but using the mole ratio, I should have 130 centimeters cubed. So that tells me 200, that's how much I've had total, right? How much I should have is 130 centimeters cubed. How much I do get is 130. So what is in excess? 70 centimeters cubed. 200 minus 130. 70 centimeters cubed of what? Of oxygen remaining. And there you go, C. Question 22, which statement is correct about reactions involving halide ions? Just how well you know your equations in group 2 and group 7. So you should be able to spot is C. Sodium bromide does form bromine when added to concentrated sulfuric acid. And yeah, and then 23, what percentage yield when this much are produced from this much? It's not 20 divided by 50 times by 100. It's not that. It's not that. It is. This one's a bit of a tricky one, but percentage yield is actual yield or theoretical yield. So I know this much is actually produced. So I'm going to work at the moles of aluminium oxide, 50 divided by the MR of this. Aluminium is 27, oxygen is 16. Then, because it's a 2 to 4 mole ratio, I'm going to times it by 2. And then I'm going to use moles equals mass over MR, mass equals moles that I've got times by the MR of aluminium, which is 27. And then I'm going to do 20 over the actual yield over the theoretical yield times by 100. I get 75.5%, so therefore 76%, because 75.5 recurring. Remember, with percentage yield, you don't include the moles when you're finding out the MR, but in atom economy, you do. And that's a clear distinction.